Here we have this vessel, and let's divide the main items of this vessel. We have an ellipsoidal head here. After that, we have a can. Okay, this can with that length here. After that, we have a cone, another pipe. After that, a flange. Okay, so let's start creating the main items of this equipment. From here, we will open SEG Software, and from new, we will create a new project. Demo. And let's select the location to be on the desktop. And from here, you will be able to select the module that you would like to generate, like if you would like to generate a heat exchanger or storage tank or duct, or a pressure vessel, vertical or horizontal pressure vessel. The difference between modules here, that each module will give you some features suits this module. Like in heat exchanger, you will get items like tube sheet, for example, and some features give you the ability to make the tube pattern and the tube holding. In ducts, you will find the duct features, and on tanks, you will find features give you the ability to make a bottom and roof plate arrangement, like that. Let's select the vertical pressure vessel and click on Finish. Now SEG will start creating the project files on the directory. Okay, and from here, that's the equipment, and that's the project itself. Here, that's the project. You can define the project information here, like the client, plant name, manufacturer. After that, you can save those information. Those information, you can reflect them in your title block on the final drawing. Here, that's the equipment. So let's rename this equipment to water SB, for example. That's the equipment name. Here, that's the design data for this equipment. You can change it and define it. Like you can change the construction code, define it, design the design pressure values and the units. You can change that, and if you have an Excel sheet, you can import it directly from the Excel sheet. Many different ways to deal with the design data. Another thing regarding the equipment, which is the equipment setting, you can define the equipment position automatically in case of using a vertical module, vertical pressure vessel module. Those values shall be changed automatically to vertical and bottom to top. Here you can define the service of this equipment, the tag number, serial number of this equipment. By the way, those values will be reflected to the title block automatically. Here, another more option for the delivered plate dimensions, which is the raw plate dimensions. SEG will use those values. By the way, those values are very important on calculation of roof and bottom plate arrangement. And if you have a large diameter vessel, SEG will use those values to calculate the number of plates per sheet. Okay, you can control the units. You can select between metric or inches. Now let's proceed creating the elements of the main elements of this equipment. So let's select the equipment itself. After that, let's add the first element, which is an ellipsoidal head. The nominal thickness diameter is 16 millimeters. The minimum thickness after forming is 13.5, and the ratio 2 to 1. And here the inside diameter is 1630. So okay, so from here let's select head, define it as a bottom head, and let's select the first element. And from this list you will find more than 17 types of different type of heads. You can select the suitable type for your case. In our case, we will select the ellipsoidal head. Let's define the inside diameter, thickness 8, flange to be 50, minimum thickness of performing 13.5, and let's make this head as flipped head to make the convex to bottom. After that, let's add a shell course. So from here, let's add a can one. Okay, and from here, you will find many different type of shell courses. And for our case, we will select this type, which is shell, define the inside diameter, define the thickness, longitudinal welding line orientation, and the length. And let's click on save. Let's add another can. And let's make it look like can one. And by selecting it, you will find that the type will be the same dimensions. Let's change the longitudinal welding line orientation and the length. So we come back here and get the total length of the shell. Here, that's the total length of the shell. So let's open the calculator. 5297. So that the second shell course length. And let's click on save. Now let's add a cone. Okay, in our case it's a eccentric cone, and here we have the start inner diameter. So if we come back here, so here that's the outside diameter, not the inner diameter. So let's calculate the inside diameter. Okay, that's the inside diameter of the cone. So let's define it here. That's inside diameter. The thickness is 16. Let's keep the longitudinal welding line as it is. Here we have the length of this cone, 1T, and here the end diameter is like that, and let's click on save. Now let's add the second piece, which is a pipe. Okay, it's 26 inches, I think. If we open the Trouvé, okay, it's 26 inches, so that's the outside diameter of the 26. So from here, let's add a pipe. So let's name it as a can 3. And from here, we will select the pipe, not the shell or different types. So let's select a pipe, and from here, let's select 26. And you can select the suitable schedule. And if you would like to define a certain thickness, we can define it from here as 16 like this, or you can select one of those values directly, which is the standard schedules. So I think most of them is far. So let's define it manually, make it 16, and define the length of this pipe. It's with the flange, it's 300. So let's make it 200 right now, and add the flange from here. Let's add a cover, a body flange. So when we select this, you can select between many different standard types. And in our case, let's select ASME Welding raised face according to P16.47 Series A. Select the rating, keep it 150. Select the size as 26. Define the end thickness to be 16 and flipped. Click on save. Now let's start assembly to start to generate the 3D model of Here, SEG start sending commands to Autodesk Inventor to start creating sketches, parts, and creating the assembly automatically of this equipment without any hand modification, just sending some commands to generate the 3D model. And you can imagine how much time you will spend to generate, for example, an ellipsoidal head like this if you start creating a part by hand and creating a sketch. But in case of using SEG software, it's just seconds to generate and create those items by using the SEG software. Here we have the main elements for the this equipment, including the flange, conical connection, and the shell courses. And any time you would like to make a modification, for example, if you would like to change the longitudinal welding line orientation or the shell length, just select the node from the tree and redefine the values from here. Click Save and Run again. Now let's add a skirt to this bottom head. So I forget to inform you about an important thing here. When we select the equipment itself, you can figure that you can add many different items to the equipment. Here, those items are available for the vertical pressure vessel. In case of using the overall module, you will be able to add ducts. Here you will find duct features, for example, spherical tank features, storage tank features, tube sheet for the heat exchanger. Many different items will appear here. For the main items, for example, you can add heads, shell, and we discussed that in head, for example, you will find more than 17 types of heads. For shell, more than 10 types of shell, chamfered shell, cones, centric or eccentric from blade. And if you would like to use standard fitting, here we have a tab for the fitting. You can select standard fitting like elbows, T's, cones, couplings, hex nuts, many different things. Here for the flanges, you will find many different type of flanges, standard flanges. So here that's one of them. You can add a long weld neck flange according to ASME, slip-on threaded lap joint, weld neck RTG, which is ring joint flange, or with a raised face flange. Many different types according to the European codes or the ASME. So many different types here you can add in. In case of selecting a main item, this element tab will be changed to the attachments. So each main item you can add attachments to it. Like when you select a shelf, for example, you will be able to add skirts, stacked saddles, legs, lugs, anchor chair, different type of cradles. You will be able to add nozzles with different type of nozzles with external and internal connections, couplings, clean outdoors, weld outlet, stud outlet, couplings, connection. You will be able to add lifting lugs, many different type of lifting lugs as we discussed in our presentation, external attachments like nameplate, external pads, top davit, grounding lug, earthing lug, external stiffening rings, nozzle, ribs, nozzle support, ladder clips, insulation clips, many different things here. And the same for the internals. You can add longitudinal plates, impingement baffles, deflectors, bundle retainer, many different pipe supports. So here to add a skirt to this bottom head, we need to select the bottom head first. During the selection, the element tab will be include the available items that you can add it to this bottom head. And from here, let's select the skirt. Okay. And let's select the suitable type of skirt here. Let's check some dimensions here. So the skirt thickness, any detail for the skirt thickness here. Okay. Okay, we have a detail here that mentions the thickness of the skirt is 10 millimeters, but another one here informed that it's 16. Okay, no problem. So if we calculate the inside diameter of skirt, the inside diameter is the same of the shell and head. Okay, so let's come back here and define the inside diameter. Okay, the thickness, the longitudinal welding line orientation, the length of the skirt. So if we come back here, and that's the height of the skirt from the seam line. Okay, so it's measured here on the drawing from the tan line. So we need to decrease this value by 50 millimeters, which is a straight flange length. So that's the length of the skirt. So that's the height of the skirt. Okay, the material, number of sheet plates, the inside diameter of the base plate. So that's the base plate. 1.35. The outside diameter. So here in 1.30. The base plate thickness 25. Bolt circle diameter 1,900. Okay, the hole diameter. So let's check the hole diameter. Is there any detail for that? Okay, that's the base plate. Here we have, yes, the hole diameter is 38 and number of holes is 24. Okay, so 38 and 24 holes. Okay, let's add ribs here. That's the rib spacing. Let's keep it like that right now. Top of the rib. Any detail for that? Yes, here. That's the top width of the rib. So with this value. Okay, so that's the top and the bottom width of the rib. So let's come back here, define the top and bottom width. The rib height. We come back here, that's the rib height. 350, 355, and the rib thickness. Okay, the rib thickness, any information here for the rib? Okay, here, yes, that's it. Here the rib thickness is 15 millimeters, and we have a top ring. So let's select the top ring from here. Define the radial. Let's make it the same with the hole diameter as the top ring. That's the base ring. Here, that's the top ring. It's the same, 38. Okay. And the top plate thickness. Back here, the thickness is 20 millimeters. Okay, so let's define it as 20 millimeters. And you have the ability to add 4 segments from the skirt. If we take a look to the image here, you can add, as you can figure, 4 different courses, and you can control the thickness of each course, the material of each course, and you can change the longitudinal welding line orientation and control the number of welding lines per course. You can add a tailing lug, and you can add a bracing beam if you would like to add a bracing beam here and a tailing lug. But right now, let's save this as it is and run the assembly. Before running the assembly over Autodesk Inventor, I would like to discuss here another feature. As you can figure, during the creation of the 3D model here, we create the 3D model, and SEG create everything on behind. If you would like to make a presentation or rendering for the element during creation, we need to select those options. Okay, any questions? Hello? Okay. So let's select the child preview and the parent preview. Let's click on save, and now let's click on start, simply to start creating the skirt. Here, as you can figure, the assembly of the skirt will be created and rendered on Autodesk Inventor, and you can see the elements during creation. The first option, which is without using the rendering during creation, everything will be created on behind. After that, it will appear one time at the end of the assembly. Here you can figure that the base plate, for example, now created and will be assembled automatically to the skirt course. Okay, now the skirt assembled to the final assembly of the equipment. Now let's add some attachments like the nozzles. Here, if we come here to this nozzle with internal elbow, here we have N1. Okay, so let's check N1 here. It's 16 inches, 40. The schedule is 40, and the rating of the flange is 150, named gas inlet. Okay, so with the reinforced bed here. Okay, and the reinforced bed thickness. Okay, and let's check the location. Now let's come back to SEG and select CAN 1. And from CAN 1, you will figure that the elements here we can select nozzle type B, which is nozzle with internal and external connection. So from here, let's add N1. And when we select N1, you can select the type of the nozzle. As we discussed, there are many different types of nozzles, from pipe or forged nozzles. That we will select the nozzle from pipe and select the size as 16, it can be 40, add a reinforced band width and thickness. Here, define the location. So let's come back here and calculate the location of this one. So that's the location from the base plate. So we will minimize the skirt height. Here's the skirt height, which is 303. So that's the location of the nozzle. So let's select this location from here and add it here. Define the orientation of the nozzle. So where is N1? Yes, that's it. It's on 270. So the projection, let's keep it like that right now, and the nozzle serves as gas inlet, and the projection, internal projection, and click save. Now let's add a flange to the external connection of the nozzle. So the nozzle, this type of nozzle, you can figure that you have an internal and external connection. We will select the external connection and add a standard flange. So here let's add N1 flange, and let's select this flange. And from here, let's select Welding raised face according to ASME P16.5. Keep the rating to be 150. Select the size and the schedule of this nozzle. Click Save. Now to the internal, let's come back to the nozzle. And from the calculator, let's define the projection of this nozzle, which is the projection from the facing of this nozzle to the center line of the vessel, this projection. Okay, so let's come back here to this calculator and this value, for example. We need to decrease it a little bit. So let's take that. Okay, and let's click on Save. Now let's add an internal connection. So we will select the internal, and you can figure that you can add all of those types. In our case, we will select the elbow. So from here, let's select N1 elbow. And you can figure that many different type of elbows here. You can select the suitable type for your case. We will select elbow 90 degree as a long radius. Define the size, define the schedule, and click on Save. You can control the orientation. Let's add an internal deep pipe. So N1 pipe. Here, select the pipe, define the size 16 and the schedule, and let's check the length. Okay, we have this pipe, so the length of this pipe is 2593. And let's click on Save. Now let's create the assembly of this nozzle. So each element you can figure that it's created and assembled automatically. And I will give you a sample to show you how much time you will spend if you would like to generate an item like this by hand. Here, that's the elbow with the long ridges. Okay, here, finally, external flange. Okay, now we have this nozzle. If we take a section to the model to check the interior, now we have this nozzle with the deep pipe like that. Okay, so here, for example, if we would like to create a flange, for example, if we would like to generate this flange by hand, I will do that to show you how much time you will save in case of using the SEG instead of the hand using. Here we start generating a new part, and from here, from the sketch, let's select a plan to start drawing, and from here let's create a center line. Convert this type to a center line. Define the side diameter of the flange. Make those as a construction lines. Define the contour of this flange. Let's make this line as a horizontal line like this. Now let's define the dimensions like that. Raise the face diameter. Height. The total height. As you can figure, you will need to define each dimension, make each line by hand, like that. Finish. Now we have the first sketch of the flange. Let's make a revolve for this one. Now we have this flange. We need to make the hole pattern. So from here, let's draw the whole circle diameter, define the hole orientation. Here, define this as the whole circle diameter. Find all of that as center lines. Create a hole, define the hole diameter. Make a pattern for this hole. Now after creating the 3D model of the flange, we need to add a user coordinate system. So it will take more time. And from here, you will need to change the material. Let's select steel, for example. Okay, so you will need to define the steel, change the color of this one. So all of that from an expert, you can see it takes, let's say, 5 minutes or 6 minutes to generate something like that. And we assumed the dimensions of the flange, for example. But in case of using SEG, all of that in database, so directly it will be generated in seconds. The same for any other element or any other complicated elements, because in SEG you will find, like in spiral stairs, for example, or coils or like that, you will spend a lot of time to generate that by hand. But in case of using SEG software, it's a piece of cake. Okay, now let's add a lifting lug to this can. So if we come back here, we have lifting lugs, and let's check the detail of the lifting lugs. Here we have this lifting lug. Okay, so that's the width and height. From elements here, let's select the can first, and from here let's add the suitable type for this lifting lug, which is type lug 5. So lug, and select the lifting lug node from the tree and start defining the dimensions. Let's add a wear plate, and from here let's define the bottom width and the height. Do you know what I mean? And the thickness of this one, it's 10 millimeters the thickness. Okay, and if you would like to add a fillet or remove the fillets for the pad, and you can control the fillets. Okay, here let's define the dimensions of the lifting lug. Here it's 23, the total length 600, so dimension of 2600 negative 90, so that's the total height. Let's minimize the hole from the top. So that's the dimension D. Dimension E, let's okay, 500, okay, like that. Yeah. So the lifting lug is 20. Okay, the chamfer is 14. So let's make it with the chamfer ends. Here's the thickness 20. Radius F we will not need it. The hole diameter is 75, so, and lug cut, we have a cut on this slug K 80 130 K 80 130. If we have a fillet, we can add fillets, but it's a sharp corner, so let's keep this. We haven't a cooler, so we will not add a cooler. The offset L, which is the offset between the end of the lifting lug and the reinforced pad. Here in our case, it's not mentioned here, so let's make it 50. Okay, make it 50. Location of this one. Let's make it right now. Here, as we calculate this shell course, when we calculated the length, F كيف 2200 تساوي 2150 مثلا. The orientation, if we take a look to the orientation view for the lifting lugs at 0 and 180, so the start one, we have two lifting lugs, and let's click on save. Okay, one more thing, let's add a support rib, which is this rib at the top, the rib here. Let's take a look at that image here, that rib. Okay. Okay, so let's measure the location. 230 ناقص 20 ناقص 90 على بعد 120. Okay, so the width of this one is the width of this one. It's 230 ب 130 دي ممكن نخليه كام ده؟ نخليه 1550 مثلا في 20. قلنا كام الأوفست؟ 120. الريكتانجل هنخليها 0 and then let's click on save. Okay, here we have this lifting lug with the ribs. Okay, we need to increase the rib cut a little bit, and okay, we need to define the R, the F here. It should be to become 230 TF 230 100. Okay, and increase this one like that. Click save and update. Okay, now we have the lifting lug to the vessel. Now let's add some attachments to the bottom head, like we have a nozzle here, which is N5. Okay, so if we come back to the nozzle table, we have a drain nozzle. It's 2 inches, 80 schedule. Okay, so it's a drain. So let's select the bottom head, and from here let's select the nozzles. Select nozzle with external connection N5. It's 2 inches nozzle. Schedule 80. Offset from this center line is drain nozzle, and it's set in and parallel. And let's keep the projection as it is right now, and let's add an elbow to this one. So from here let's add N5 elbow, and select it as an 90-degree elbow, the long radius. Select the schedule, define that one, and when we come back to the nozzle and open the calculator of this nozzle, we can define the projection from the seam line. So when we go back to the drawing again here, so the projection from the seam line is 667. Okay, so let's come back here and the projection and click on calculate, and you can figure that SEG will start creating a sketch and calculate the correct projection of this nozzle. And here that's the pipe projection, the required pipe projection, and let's click on save. Now let's add a pipe after this elbow, so N5 pipe. Here, after selecting this pipe, you can select the size, which is the schedule, and define the length. So let's make it as 800, for example, and click on save. Now let's add a flange to this pipe in 5F1. Define this flange as a Welding raised face flange at the same rating. Okay, and let's click start the assembly. Okay, now we have this nozzle with outside from the skirt, and let's add a connection to this nozzle. Like here in this drawing, we have a valve, maybe a valve here. So let's add a gasket. So here let's select the external connection and add a gasket in 5. Select the gasket and select the suitable type, size, and rating. Click save. Now let's add a flanged valve. So from here let's select a valve. E1. Select the type of the valve. Let's select check valve. Yes. Select the rating, select the size, and click on save. Now let's click start the assembly. You can control the orientation of the valve. For example, if we come back here and rotate it with a 90 degree and click save, come back here. So you have the ability to control the orientation of this valve. Now let's add some attachments to the skirt, like the skirt opening and skirt vent. Okay, so if we come back to SEG and select the CAN one, and from here let's add a nozzle with internal and external connection, and let's add this one as skirt opening 1. And from here let's make it as 5 inches standard scalable, and the location will be with a negative value for the same location of this nozzle. 667 is the same orientation. The projection is 60 to the outside and the same for inside, and that's its nozzle. Okay, and let's click on start. Okay, now we have this opening on the skirt for this nozzle, like that. Okay, you can minimize the projection from outside and inside, like this. Okay, let's add another attachment to this vessel. If we take a look, for example, we have here nozzle opening, or nozzle axis, or skirt axis. Okay, so let's calculate the location for this skirt axis. Uh, add the skirt axis by the same way. Let's add. Let's make it, let's say, like that. Okay, define the location, the orientation, the projection. Let's add a repad if you would like to add a repad to this one. Skirt. Okay, and let's click on start simply. Now we have this axis, and you can figure that if you can see no need for the repad, or if you would like to minimize the width of the repad, you can modify it. So if you would like to remove the wear plate, just remove this checkbox from here to remove the wear plate and click on save. And now start the assembly to remove this wear plate from the final model. As you can see, any clashes or any interference between items, you can figure it easily, and you can, if you would like to measure something, you can measure it from the 3D model directly. Now let's proceed with the detailed drawings for this model. Here, if we come back to the tables and let's open the bill of material table, you can figure that SEG calculates the bill of material in seconds. Here we have totally uh, 76 elements. Here we have an ellipsoidal head, that's the first element, and the description of the ellipsoidal head, the inside diameter, the nominal thickness, and the minimum thickness after forming the straight flange and the material, and the weight of this head. The first shell course definition, the same for the second course, cone, seamless pipe, flanges, elbows, gasket, and the skirt opening, wear plate. All of that is included here on the bill of material. The same for the flanged swing check valve, okay, according to SME 16.10. And let's proceed with the drawings. So from here, let's select the. Okay, before proceeding with the drawings, any questions regarding to the modeling features? Okay, any
Hello,
questions?
sir. I'm Nurpay Deshpande. Hello.
Yes.
Sir, I'm Nurpay Deshpande from Ador Welding Limited.
Would you mind to speak slowly
Hello.
and to be able to hear you?
Sir, I'm Nurpay Deshpande from Ador Welding Limited. I have a question. Is that you mentioned that in SEG there are libraries for lifting lugs and saddles and everything.
Yes. Where
Correct?
is the question? Yes.
So I wanted to ask that you
Yes,
also mentioned
as
that
as we discuss here, when you select an element like this,
uh,
you will find the available
yes, correct.
attachments that you will be able to use. Like when we add a nozzle, for example, you find that a list of elements, nozzle from pipe, nozzle from plate, like that. The same for flanges, for example. When you select a flange, you will find a list of standard flanges. By the way, there are designed flange. You can design the dimensions of flange like in heat exchanger, not a standard flange. So yes, there are libraries for elements in SEG software. Okay. So is the question?
So I wanted to ask that if we use light approach for creating a 3D model,
I
can we
cannot hear
use
you.
this library to modify
I cannot hear you, please. Would you mind to raise your voice a little bit?
if we use PV Elite approach for creating a 3D model, then can we use this library to modify it?
Yes, why not? You can use it.
Okay, okay. And the one other question is that
Mm.
uh, when the assembly is created, in which format the parts are being saved? IPT format or means can we access individual part for other means since PV Elite does not do analysis of spherical cylinders, something like that for nozzles. So can we use that individual file for FEA analysis?
If I understand your question in a correct way, you are asking about the if you have something not included in BV Elite and you would like to make a finite element for it. Is that right? Or I get your point. Is that your question?
Hello, Ahmed sir Sarang here from Ador Welding. My colleague Nopal want to ask you that can we use these models? Suppose we want to do the FEA for any particular nozzle. can we use these particular parts for the FEA modeling?
Yes.
So we can
Here I
start
will,
from this model. Yeah.
okay, here I will share with you one of the tutorial videos on our channel for the finite element analysis by using the 3D model created by SEG. Here we have, after generating the 3D model of this simple vessel, we start creating a meshing, defining the boundary conditions for this model. Okay, start creating the simulation. Okay, so you can come back and check this video on our channel, how we can generate all of that, I think, in 7 minutes. Generate the 3D model of this equipment to define the internal pressure, define the meshing, the loads, all of that. But you still need to make one more step, which is the stress categorization, because the finite element analysis softwares like ANSYS or Abacus or any other don't make the stress categorization. So you will need to sum the primary stress plus 1.5 the secondary stress. All of those categories you will need to recalculate it manually. Okay. I hope the point is clear now.
Yes, sir. Thank you.
Yeah, welcome. Okay.
Mr.
Any
Hegazy,
other
good morning.
questions?
This is Vikas from Jindal Steel.
Good morning.
Yeah. Uh, I have still one doubt on this. The particular thing that you have shown, what I understand, is it possible to take this model for that particular flange or nozzle or whatever the part it is? We can export this model and we can do analysis in ANSYS also?
Yes. As for example, here this model, for example, here if you get this flange as a separate model, here you can make a study for, let's say, internal pressure, for example. So from the environment, we will open the stress analysis and create analysis study. From here, you can define the mesh values. Let's keep it as it is and start creating meshing for this element like that. So you can define or edit or modify. So let's make some changes here, increase the meshing a little bit. That.
Yeah, this is what you are doing in Inventor. But if I want to do this in ANSYS, I can take this model out over there, right?
Yes, as you know, the CAD software. As you know, all CAD software deals with the ANSYS and Abacus, all of that. So the extension itself is common, so you can take it
Oh,
on ANSYS or any other application.
okay. Okay. Yeah.
Any other questions?
I have some questions on it. That this is completely based on Inventor platform.
Yes. Yes, it's over
So it,
Autodesk Inventor.
so it means that we have to have an inventor for this. I mean, if we want to have SEG CAD, so we have to purchase additional inventor if we don't have.
Yes, because you will replace the AutoCAD with Autodesk Inventor. Okay. After that, by using SEG software, it will give you a lot of benefits to generate the 3D models and detailed drawings for the equipment in minutes.
So you are basically extracting this from PV-Elite model, right? You are getting some extension of PV-Elite and you are importing to your SEG CAD and then you are importing it to Inventor.
Okay, that's a method from many different methods. That's to make things easy for the customers. If you have a BV Elite model, you
Yeah,
can
yeah.
export the Access database file. Okay, so from the Access database file, you can you can read it by using SEG software, as we mentioned on the presentation here. Here on this slide, from the BV Elite, you will export the Access database file, and by using SEG software, you can read the Access database file to generate the 3D model. And here in this video, we discuss that by importing the Access database file, we automatically generate the tree. After that, sending the elements to Autodesk Inventor to generate it. I think I need to close the Autodesk Inventor and SEG because the Autodesk Inventor get an error.
So is there any other extension like for SolidWorks if we want to use SolidWorks, because we have SolidWorks with us? So if we want to use in SolidWorks, is it possible, or it is now it's only on Inventor base?
It's available now on Autodesk Inventor only, and we are working to develop this application over SolidWorks. Maybe available, inshallah, after maybe 1.5 years or 2 years from now. Okay, any questions before proceeding with the drawing?
Yes, good morning, sir. This is Mandar from Kirloskar, KPCL.
Good morning, Mandar.
Yeah, I have a doubt. Yes, as you just told, ki it is SEG having facility to do the stress FE analysis modeling in the
No, I didn't
Inventor.
mention that. No. SEG is an advanced tool to help you to generate the 3D model and the detailed drawings for the equipment. Okay, over Autodesk Inventor. Autodesk Inventor itself include tools for finite elements. Okay, so you can use the generated 3D model if you would like to make a finite element over Autodesk Inventor.
Okay. So only 3D model.
It's a huge thing. The 3D model, it's not easy to.
Okay. Thank you.
You're welcome.
And one more thing, sir. This the same. Suppose we do the design in the PV light for heat exchanger. So same thing also as like PV pressure vessel. It is importing the data for heat exchanger.
Okay, for the heat exchanger, the exported access database file not include information for the tube pooling or the tube sheet. So the access database file itself not complete for the heat exchanger, and we asked Hexagon PBM to develop this feature on the access database file to be able to generate the heat exchangers from the BV Elite. Right now, the access database file not including information regarding the heat exchanger.
Okay, so means we have to completely separately model it.
Yes, and as you can figure, it's easy to generate something like that, and we could make a sample for a tube bundle after creating this drawing for this equipment. and you
Yeah,
can
but is there any development to take the HTRI file, something like that, or are you planning that?
Okay, as we discussed on the in our presentation, there is an integration tool with the exported CSV file. The exported CSV file from HTRI includes the location of holes in X and Y direction, some information for
Okay.
the arrangement, so we can deal with that. Okay, and there is a separate tool in SEG give you the ability to make the holing, and we can discuss that after the generation of the this equipment.
Okay.
Here we have this equipment. So let's proceed with the drawings from here. Let's
Thank you.
select the vessel from the tree, and from this shortcut menu we will select drawing and select create drawing. And from this wizard we can control the drawing size. If you would like to make as a metric drawing, you will have the standard sizes A0, A1, A2, and for the imperial drawings you can select A, B, C, D, E sizes. And if you would like to make a special size custom in inches or custom in millimeter, in this case let's select A1, and here the height and width of the drawing, of this standard drawing. You can flip the drawing to make it as a portrait or landscape. From the active view, you will select the required views in your drawing. So let's select the elevation view. Let's add one view only, and we will make the second one by hand to make it floating on the drawing, to control the floating of this one on the drawing. And from here, the third tab, we will define the elevation view. Here, for example, if we take a look to this equipment from the left view, that will be the elevation view. So here you will select the view that you would like to make it the elevation view. In this case, we will select the back view, that one. That view will be the elevation view for us. And here's the style of lines. If you would like to make visible lines only or with hidden lines, and if you would like to make it shaded with colors, you can select this checkbox. Here the location of the equipment. So in and define the location in Y direction. All of those values we can deal with it and change it after creating the drawing to make it make sense. After that, select the tables. We'll select the bill of material table, design table, and the nozzle table. And for the nodes, you can add or edit or modify the nodes. And if you have a general node seek in Excel format, you can import it directly. So if you would like to add a node, just write your node and click on add to add it. If you would like to edit, just click edit and add. If you would like to delete, just click on delete to delete it. So those are some standard nodes. You can keep them or delete them if you would like. Here, that's the SEG welding detail library. So for this case, we will select the cone connection. Here we have this flange to nozzle connection. We have an elbow connection, for example, nozzle without forced band. Another one we have in this one, we have a nozzle with internal and external projection like this. Another with a reinforced bed, internal and external, single V, not a double V. We have skirt connection. We have something like that. Okay, many different welding details. So we will select the required welding details and click on save. Let's add a client document list table. Here you can add like the mechanical datasheet, process datasheet, any other attachments received from the client. If you would like to add a list for it, the document list, like if you will export or issue a mechanical calculation as a general arrangement drawing, nameplate drawing, skirt drawing, lifting drawing. So all of that you can add it here by the same way. If you would like to add a document, for example, like that, or if you would like to edit on it or delete it, just select edit or modify. Let's add a revision table. So the drawing name, let's make it GA drawing. Document number. And from here, the revision table, let's edit this one. Let's revisions view. Okay, click on save. Let's add some other empty rows here. And for the design style, in this tab, you can make the sheet of this drawing or this drawing include from one sheet or two sheets or three sheets. In case of huge equipment, you can separate the bill of material in a separate sheet on the GA. So the GA, for example, can be sheet 1 of 2, and the bill of material shall be sheet 2 of 2. By the same way, you can separate some of those tables in a separate sheet. Like if you would like to separate the notes and the design data on a separate sheet, you can do that and select the sheet that you would like to separate the table on it. Now let's create the drawing by clicking on Create Drawing. SEG will start creating the drawing here, like that. That's the bill of material, the revision table. Here's the bill of material table. Automatically will be filled and located on the correct place. After that, if you would like to move it or change the location of this table in the drawing, you can do that. The design data table. The general notes. The nozzle data table. Client document list and the vessel document list. After that, the welding styles. Here.
Hegazy, sorry for interrupting you.
Go ahead, please.
Hello.
Yeah.
Yeah.
Yes, I'm hearing you.
In the tall towers, I mean columns, we will be able to put all the platforms and piping clips and other things, right?
Yes. Okay. To make this point clear, here in SEG software we cover more than 5,000 elements with the different types and the connections for elements like different type of heads, shell blades, elbows, flanges, all of that. The attachments like saddles or platform clips, many different types. But sometimes you may need to make a special thing not included in SEG software. Okay, so how you can deal with that? There are many different ways to deal with that. Here, as you are using a CAD software for like Autodesk Inventor, if you would like to make a special connection, for example, and you would like to make it by hand, like it's just by sketching it like that. By that way, you can make something like that. Define the dimensions. So you are using a CAD software, so you have the ability to make anything you would like to do, like using the AutoCAD. So you can define that by that way, and you can get in your drawing by that way, or you can generate a real element as we did with the flange. You can generate this element like that.
Okay, no, but why I'm asking this, because in PV Elite sometimes we do, we model the platform even. So is SEG CAD is able to take this input also is it be possible for a SEG CAD to take that input?
Okay. For example, if you would like to add a platform to this equipment, here for the external for the platforms, you can add a vertical platform. So from here, let's add a vertical platform, and from here you can add a platform as a segment, or defined it by a start and end angle, or a complete platform like that. But take in your consideration that this platform not in detail. That means you will get it in the bill of material as a one element. Okay, not panels and angles and rails. You will not get it on detail. It's just a platform. Okay, that's for the platform. So you can add it to the final model to check if you have any clashes or any issues after adding this platform, because we are concerning with the fabrication requirements for the equipment itself and the attachments. You can add a platform attachments. Those attachments are in detail. For example, let's delete this platform. So if we select this one, and from here, for example, if you would like to add a platform support or a platform clip, let's try this and that. So from the platform clip, platform support, you can add many different supports to the platform. For example, let's add an HEA, for example, 160, define the projection. The axial orientation, let's add from here rate, add end rate.
छुट्टी में है ना, शादी में जाएगा कहीं 10 दिन,
Define the location orientation. So let's have this clip, for example.
नहीं काट रहा, अच्छी बात है, अच्छी बात नहीं, एक साथ काट देगा. हाँ ये लोग तो ऐसे ही करता है, एक साथ मार दिया, एक साथ, तो फिर लफड़ा है, मतलब एक साथ. हाँ हाँ हाँ, एरियर करके साला सब काट दिया, इसमें लफड़ा है इन लोगों को. तो क्या बोले वो, आने के बाद देखता हूँ.
So as you can see, for the platform support or the pipe support, you will get it on detail like that one. You will get the HEA camera and the reinforced bed, the end plate. You will get that on detail. Let's add another type of the supports from the elements. Let's add an platform clip.
Those clip that you have shown, we can have the detailed drawing and BOM also, right?
Again, please.
The clip that you have shown just before, we can have the detailed drawing as well as its BOM.
Yes, yes.
Okay.
That's I'm talking about for the platform clips or ladder clips, or you will get it on detail. Okay, but regarding the platform, you will get it as a one solid element.
Okay. So, is there any plan in your future edition? Are you adding this platform? I mean, detail of platform like grating, railing, and other things. Because sometimes the scope is including these platforms and all.
Okay. Here in Autodesk Inventor, you can generate steel structures by using the frame generator tool, which is the design. By using this tool, you can make any shape, because actually for the platforms, it's not takes the same configuration. It's different. You cannot control the shape, but we can make some standard configurations for the platforms in future. Okay.
Yeah.
As discussed, you are dealing with a powerful CAD software, so you can do many things, a lot of things you can do besides the SEG help. You can make many different things. Okay. Here we have, for example, we add this support here, and let's add another type of the clip. We add this type of clip. You will find many different type of support clips. Let's select this one and define the length, which is dimension A, and the location. Define the orientation. Let's add a wear plate. Let's add a fillet and the blade. Define the length. Let's click on save. Let's start simply. So as you can figure, therefore those clips, each element created separately, and each one of those will be included on the bill of material as a separate part. And you can get a detailed sheet metal for it if it's a chrome blade. For example, here for this support, for example, if you open this clip, you can get the sheet metal development for this one. If we click on sheet metal development, you will get a development of this blade. For the wear blade, for example, if we open the wear blade like that, you can get the sheet metal development for this one, the line. For the cone, for example, if we open the cone here, that we have this cone. If we click, you will get the shell development or blade development. This cone, like that. Okay, now I will update something here on the setting. I will delete this and regenerate general arrangement.
डिडक्शन 1800 रुपये EPF है. हाँ. ठीक है. इसमें 1800 ये माइनस हुआ ना. हाँ, कितना हो गया? नहीं, तुमको फिर ये यूनिफॉर्म अलाउंस, चिल्ड्रंस अलाउंस, कंपोनेंट अकोमोडेशन, ये HRA मिल रहा है? ये 3 महीने बाद मिलता बोलते हो ना? क्या? क्या सर?
Any questions before proceeding with the drawing details, and we can add dimensions and notations by using the SEG features?
Here, one question more. Some components are not included in the SEG software, so we can add them manually, correct? So
there
the
are
added
different
components.
ways.
Yeah, correct. So we can directly draw it on the drawing, or we can create a 3D model and then assemble it on the assembly. Okay.
Yes.
So will that be
Third way,
in the bill of
the third way, yes, the third way, by the way, the third way, you can send us, share with us the information for this element, and our technical team can include it on SEG library to be able to use it anytime. I will give you an example for that. Here, for example, when we some of our customers asked us to add some items like different type of the top David. Okay, it was not included in SEG from months ago, and some of our customers asked us to add it. Here, if we open the elements and the external attachments like that, here we include those many different items. We do them by that way. Some of them this type of saddle, the saddle with the lifting lugs. Some of our customers usually used this type of saddle with lifting lugs. They are a heat exchanger manufacturer, and they usually using this type, and they asked us to include it in SEG. So now it's available, and any user can use it. Here for the top David, for example, we include this type of David, so anyone can use this type by defining the dimensions and the size of the pipe, the capacity, all of that. Another type for the top David based on some standards in BIP standard. Okay, so you can select the standard size, and if you would like to make your manual modification, like by clicking on user defined, you will be able to define the dimensions manually like that. So if you would like to add this item on the drawing, you can add it like what we did. Create a sketch like in AutoCAD, add a sketch on the drawing, or create the 3D model and add it to the assembly. The third way our development team can help you to import it to SEG library, and you can use it anytime after that. Now let's add some notifications here to this model, like add some dimensions. Here we will add the inner diameter of this course, this course height. Let's add a tan line. And measure the tan line from here to there, to the facing of this one, and the saddle or the skirt length. Okay. Here we have this nozzle. Let's define the reference point. That's the location of the nozzle. Let's add the nozzle tag. So in the Autodesk Inventor drawing, you will not find those type of bill of material like the nozzle tag. You will not find it. But in SEG software, you will get those notification, which is the nozzle tag. So you can, when you will select the nozzle tag, you will get this information for the nozzle. That's the skirt axis. Let's move those dimensions like that. Yeah. And if you would like to add a detail for, let's say, for the blade development for this support here, that one. So if we open that one, and when we, for example, just if you would like to add a detailed drawing for or sheet development for this one, just create the flat pattern. Let's move it here, rotate it, change the scale, so you can get the blade development for this blade. So by that way you can add many things to the final drawing. You can add a notation like the tag number, part tag. Here we have this head as an ellipsoidal to 1. The inside diameter, nominal thickness, minimum thickness after forming a straight flange. For this pipe, for example, it's NBS 16, scalable 40, length 2593. Here for this flange, for example, you will get this description for this plate, for this one. So you can get many things by the tools available on the SEG drawing. So let's add a vertical or a top view for this one, and you can make it floating. So let's break the relationship here. So let's break it and move it a little bit here, and let's change the scale. We have view like that. Here, let's add the to make it center line. So you can add the bolt circle diameter. For example, if you would like to add a detail for the base plate or top ring, you can add it like as we did here with that one, and you can add the tag of the element at the 0 degree, the support, another nozzle. So let's add an attachment for this nozzle, which is N5, and a tag for the N1. In minutes, you can generate the detail drawings, and if you would like to make refer for a welding detail, for example, here if we take a look to the cone to shell connection from the large size to small size. So let's add some welding details. 1, 2, 3, 4, for example. So let's define the connection here. So let's select W4. So the connection here will be related to this building style. By the way, you can add some standard blocks in SEG like the north direction, different shapes. You can add a nozzle load shell or nozzle to head. You can add some nozzle loads to the nozzles. For example, for N1, for example, if you would like to add a nozzle load on this one, you can select this option and define the nozzle load on this one. And when you open the nozzle load, you will get those loads for this nozzle. And if you would like to export it in your drawing, you can do that. One more thing regarding the nozzle table here. If you take a look to the weld style of this nozzle, you can control the weld style from the nozzle itself. From here, if you select N1, for example, and select the weld style, you can figure that the SEG standard welding style is and you can control if it's single or double V. Okay, and if you would like to make it without clad or with a clad to parent or clad with to parent or nozzle, and define the weld size like that and click on save. So when we open the nozzle table, you can figure that the weld style will be changed and the values of this one shall be changed. Now, if you would like to reflect that on the drawing, here if we come back to the drawing, the value is not changed. To reflect that on the drawing, we can make it like this. Come back to the drawing, and from create drawing, let's come back to the tables. Let's remove all tables and keep the nozzle table only. And from here, let's select update table automatically. This option will give you the ability to update the selected table. And let's click on create. Now, so if you would like to update the bill of material in case of updating the bill of material or any other table like the design data table, you configure that the nozzle table here now updated. Okay, so when we make a zoom to this table, you configure that the weld style now change it for this nozzle. Okay, any questions regarding this part?
Yeah. Hello, Sarang here from Ador Welding. There is one question.
Yes.
How can we mark the revision mark and revision cloud for the changes what we do in the next revision drawing?
Okay. After creating the first release of those drawings, you can save it on AutoCAD or DWF like this or PDF extension. On the next revision, you can, for example, let's add, we have a change here on the design data table or on the orientation of some nozzles. Here you have some the standard blocks. You can add a block for the revision, for example. Let's add a revision for the revision mark for revision 1. So let's copy this and paste it here. Let's insert, sorry, let's add a new one. Paste. Okay, and let's edit this one. So that's the mark of modifying something. So you can add a revision mark like this on the changed area. And if you can add the cloud by two ways, by using the design review tool or by using the PDF cloud. If you have the PDF, you can add a cloud on the PDF, or by using the design review, which is this tool from Autodesk. It is for free. So you can import the drawing on it and add the clouds by using the revision marks here. So if you take a look for the mark and measurement, so you can add stamps on the drawing, add samples and revision marks or clouds. I hope this point now become clear. Any other questions?
Sir, one more thing. So during, if you want to, I want to revise the assembly or drawing of that drawing. So can do I have to if I want to change the nozzle orientation? So do I have to go to the SEG application and do it, or I can just do it from my Inventor application?
Okay. Here you are dealing with a CAD software, so you can make the changes. If you would like to make it manually, you can make it manually. But we recommend making it from SEG software. Why? Because when you change it from SEG, for example, here if we open the this nozzle, which is N1, here you can figure that the orientation and location stored on the project file. So any change will be stored on the project file, not modified manually, and it will be reflected to the some other information, like for the nozzle table here, you will find the orientation of the nozzle appear here on this table. So if you make it manually, it will not be reflected here in SEG. So we recommend, if you would like to make a change, for example, let's change the orientation of this nozzle to 90 degree, which is N1, and let's update it. So you can figure that the orientation of the nozzle changed now, and when you open the drawing, automatically it will be reflected. That's the old location. Now after updating, you can figure that the orientation of this nozzle now changed. Just adjust some dimensions like that, the balloon. And if you would like to make it manually, you will lose this benefit, which is storing the information of each element in the project file. As you know, you can make that manually. Let's change it manually. If we come back to this nozzle, here, that's the nozzle 4. If you open the information here, you will find the orientation of this nozzle at 90 degree. By the way, you can figure that SEG create all of those parameters, all of those sketches here. SEG create all of that. Okay, so when let's make it on 45 degree, which is the orientation. Let's change the same for the wear plate. Okay, so here that's the nozzle, and we need to change the same value on the wear plate. So here, if we come to the orientation 45, you can figure that you have the ability to change it manually, but we don't recommend that. And when you come back to the drawing, it will be reflected. Okay, if we take a look to the top view, here if we and the center line here, if we measure the angle, it's 45 degrees. Okay, any other questions?
Thank you.
You're welcome. Okay, any other questions regarding the drawings or modeling?
Hello.
Hello?
Can you just zoom in the BOM portion?
Again, please.
Can you please zoom in on the bill of material portion?
What do you mean by bill of material portion?
Just we want to check the format, how the bill of material is generated.
No, actually, Ahmed, they are asking to zoom in the bill of material part.
Okay.
Okay.
Okay, the bill of material will be exported in that format: the item number, the quantity of this item, the description of this item. Okay, if it's a head, shell, pipe, flange, elbow, and the description of this element, technical characteristics of this element. For head, for example, it's an ellipsoidal head, 2x1. the inside diameter, nominal thickness, minimum thickness after forming straight flange, material and weight. If we select an elbow, for example, that's NBS 16, schedule 40, 90-degree long radius according to SME B16.9 for an the standard hot rolled like HEA. That's the description of this one, like that.
Okay. Hello. Yeah. As per our practice now, for the shell or what can elements now, we provide the circumferential length, not the ID or OD. So, is it possible to do this that way?
I don't get your point.
Uh, just for shell elements now, our practice is we do not mention the here you have mentioned the ID then thickness now. So our practice is to mention the circumferential length and thickness. So we can get the plate length.
If any description, okay, the flange description is that NPS to Welding RF and like that way. Suppose we have to change the description, can we able to do that?
No, that's the standard description. That's the standard description exported by SEG. You cannot, if you would like to change it, you can make it manually, but you will lose the you will lose the ability to change it from SEG.
Okay.
Yeah, I just want to ask you for the if you go for the shell elements now. Okay, here what is mentioned the PL ID 1630. Instead of that, we want to mention the circumferential length.
I get your point, but it's not here on the standard on the standard
Yes.
bill of material of SEG. It will be exported in that format.
Okay, okay.
If you would like to modify it manually like that, you can go to this row, for example. It's a plate. We will remove this ID and make it length equal.
Control on work.
Like that. If we click yes, it will be reflected here, like that. But
Okay, and one more question. Can we get the consolidated bill of material? Suppose here many items are made from 16 thick plate. So can we get the total quantity of the 16 thick plate?
total quantity of what?
Suppose here we can see now many of items are the made from the 16 thick plate. So can we get the total combined consolidated total how much quantity of 16 thick plate we require?
Yes, I get your point. That need a nesting study. So by using the nesting tool from Autodesk here, as we discussed on the presentation, I think we didn't discuss it on detail. Yes, by using the nesting tool from Autodesk, you can make nesting study for the elements like that. If you take a look to the top left side, by using the nesting tool, you can make arrangement for plates in your project to get how much plates you will need in this project. I will show you something already done for project. here, something like that, like making a nesting for plates to calculate the required number of plates by using the nesting tool, and SEG will help you to export those plates to start your study. Okay. Any other questions?
Hello. One more question.
Yeah.
Here now we have separate ERP system. In this system now we have defined the particular codes for the particular items, each and every item. Suppose for flange we have particular code. So can we add these codes in the BOM? Is it possible?
What do you mean by a separate course
Uh,
or Flange?
Currently, we are using ERP system for material release to manufacturing or purchase department.
Yes, I get your
So we
point.
have,
ERP. Yeah.
yeah, we have separate
As,
item
as, as
code.
you know, as you know, the ERP systems are different, like SAP, Microsoft Dynamics, and many other ERP systems. So if you would like to make an integration between the current ERP system in your company and SEG, SEG development team can do that, inshallah.
okay.
So if you
Means
need more information, we can make an integration between the ERP system from your side with the SEG software.
Yeah, because what now we have the item codes which are already defined. Suppose we have 2-inch flange, 150 rating. So we have the particular item code for that item. So it will make us easy if we include these ERP codes in the BOM also. Customize करून. battery.
Okay, any questions?
Hello,
Hello?
hello. This is Sachin from Kirloskar. Actually, I want to know about internals, means demister pad, like trays. We can add this in this model.
Okay. As mentioned in SEG software, when you select a parent item like shell, and if you select the internals, you can figure that you can define some items like demister, here, deflector, impingement baffle, trays, internal
Okay.
rung, cross beams, front pass partition, baffles, vortex breaker, pipe support, clad, internal stiffening rings or support ring. And if you have special configuration for a tray, for example, as we discussed, if you have a special shape not included in SEG, you can do it by three methods: by drawing it on the 2D drawing, like that. Let's add something like that here. Define the dimensions and make a pattern from this. For example, it's just something like that by hand, like in AutoCAD. You can make it by that way, or you can generate the 3D model and assemble it with the assembly, or share the information with the SEG development team, and we can generate this configuration for you and add it to SEG library. Any other questions? Hello? Any other questions? Fawzan, would you like to say something before? Hello? Hello?
I think Kausam is on hold. Something is not.
Okay, one more thing I would like to discuss regarding the cube pattern arrangement. Let's create a new project for heat exchanger. Let's select desktop, select the heat exchanger. Okay, here let's add a tube sheet. Here, as you can figure, the tube sheet feature appear, and the gasket was partition, expansion joint, all of those items are related to the heat exchangers, so they will appear on the tube sheet module or heat exchanger module. Here we have this tube sheet. You can select between different types of tube sheet. Let's keep those dimensions as they are, and from the tube sheet pattern, here we can make the tube pattern arrangement. Let's define the inside diameter of the heat exchanger. 500. We as the clearance. The tube outside diameter, the tube hole clearance is a picture circle diameter. When we click on draw, you can get the tube hole like this. You can select the pass partitions. So when you select the pass partitions like this, you can define that by that way. When we can change the tube pattern arrangement and select the tube big point. So when we make it like this and click on row, you can make it centered. Let's select this configuration and row like that. You can control the vertical bus lane if we change the number of passes like that. You can get the number of tubes per pass partition. Here we have 15 tube, 21 tube, 22. You can move the tubes up and down. When we select this pattern arrangement, we can make them a little bit near to each other like that. We select this option and for that option and click on row, you can convert some tubes to tie rods, and for example you can convert that to a ceiling rod. If we come back to the generic tab and increase the size, here we make a new feature, give you the ability to make a huge diameter heat exchanger with a huge number of tubes. For example, if we make heat exchanger with 3 meters inside diameter, when we click on row, you can figure that you can make the tube pattern arrangement for a huge diameter to make it 5 meters. Actually, no existing software can make this number of tube arrangement up to 15 meters inside diameter and make the tube arrangement. So let's make it 1 meter, for example, and click on row. Now let's check another option for the top nozzle clearance and bottom nozzle clearance, right and left. And let's click on row. So you can figure that we make a top clearance for the top nozzle, bottom clearance for the bottom nozzle, left and right clearance, and that's the arrangement. So let's make it a little bit make sense. Let's make it click and row. You will get this arrangement of tubes. As we discussed, you can control the tie rods and ceiling rods if you have. You can remove some tubes. For example, if you would like to remove this tube, just click remove. And if you would like to, when we come back and like that, in this area, for example, if you would like to add a tie rod by importing something like that, you can add a tie rod like this, and from here you will get this form. You can define the location of this one, so let's make it like that, and save to add a tie rod like this. And if you would like to edit the location of this tie rod, you can modify it easily like that, so you can change the locations. The same for ceiling rod. So I would like here in those minutes I discussed the feature of making tube pattern arrangement for the tube sheet by using this tool in SEG software. Any questions before closing this session?
Many questions?
Yes. Yes, go ahead.
Mandar.
Hello?
Hello, Mandar. Do you have any questions? Satish, are you there?
Hello, Fauzan Sarang here. We have no more questions. Yeah.
Okay, fine. Okay, so from Kirloskar side, Danaji, Bandar, is anybody having any questions? Mr. Anand? So I think, Ahmed, there is no more questions now.
Okay.
Vijay, you want to ask something? Fine, Ahmed. Okay, so Mr. Vijay has texted something. Can we show the spare quantity in the BOM, in the bill of material?
No, you can add it as a mark. Here for example, if you would like, here on the bill of material, there is a remarks tab. If you would like to fill it, you can fill the remarks tab for this element, and it will be reflected on the bill of material. So by using the remarks column, you can add any information like spare parts or information regarding the material itself, the delivery of the material, something like that. Okay.
Okay, the system requirements is, as I said, whatever the system requirements will be for the Autodesk Inventor, the same will be applicable. Because SEG is a very light software, so as I said, need to check the Autodesk Inventor system requirements. Or maybe we can share you the. I hope, Ahmed, we are having the system requirements, right?
Yes, it's available on Autodesk website.
Okay.
That. Okay, here that's the requirements for. It's the recommended. You can use minimum than that, but that's the recommended for the huge.
Yeah, minimum can be used. Right.
Yes, yes, sure. Because I'm already using minimum than that.
Yes, yes. So, Ilan, I hope your concern has been addressed over here. Any other questions? If you have any issues with the audio, you can type it on the chat box and we can address it. Or else any issues are there, any questions still pending, you can email me on my address, and then I will coordinate with Ahmed, and then I can provide you a solution on that. Okay. Ahmed, yes, you can close
Okay,
the session.
thank you so much.
Thanks for
Thank
your
you
time.
so much. Thank you.
Thank you all for your valuable time. Thanks, Ahmed.
Thank you.
For
Thank you so
a
much.
wonderful presentation.
Thank you so much. Have a nice day. Assalamu alaikum.
Thank you, sir.